we have a monster that come in for repair. Is the Krell KSA 100. Is a very big beast. It's really a monster, and we shall bring it here because he said that someone work on it in one channel and mess it up, and should work one channel and the other channel should have some problem. So this is a dual mono block, has two separate power supplies for each channel, and definitely there is no space that will gonna fit on my working desk. So I need to take apart, take only the motherboard and PCB for one channel, and power it with my bench power supply, and try to figure out what's going on. And here we go. This is how it look inside. So we have one channel properly here. So this is one channel and this is the second channel. So he said that this channel is working, so I look around and I can see everything is connected. This channel I need to take out, so all this apart, this is the power supply now, so I need to take out only this one outside from this amplifier and put it on my table and work on it, because in this side, see, we have cable disconnected. I can see there disconnected also there. So practically I need to take this one to see how this one comes out.
Thanks for the sub!
From these bolts, and then just pull it out, put it on my desk, and try to see what's going on. So we have a monster that come in for repair. Is the Krell KSA 100. Is a very big beast. It's really a monster, and we shall bring it here because he said that some Can you hear me, guys? Huh? It is working. It is working audio. Huh? It is working audio. Okay, but let me try to put that one from the camera. I don't know what happened. The computer didn't update and I don't know what happened. That's why I come late, because he was doing an update. That's why I couldn't start at 8 even. Let me have a look at something. Because I can't find the... Yes, audio is enabled. Okay. Alright. Let me try now to see if I find it over here on my OBS. Is not. Why? Ah, it's this one. Okay. Audio is there. You can hear me now? Because now I put to the audio from the camera. I thought I don't need to stay with this microphone on me. Sound like a fan or extractor going on the background. Yeah, it was my computer. That's why I want to put on this microphone from the camera, because it has noise cancellation. And I have now is the sound is okay. Yeah, I don't know. Around 8 o'clock, computer did an update on Windows, and then I had everything ready to start. OBS shut down not properly, and then when I wanted to start OBS, was telling me play on safe mode. Then I needed to do again some resettings. That's why it take me a bit longer to don't start at 8. And then also my little boy is not yet sleeping. He's in the other room on his tablet. Maybe time to time he will gonna might scream, call me. All right, let me go through the chat because I didn't even say hi to everyone. So we have psychical specialist. Good evening. Carter, good evening. PITCO, good evening. JFix, good evening. Who else is here? Who else is here? Dave Zambrandent, good evening. Chris F596, good evening. AVBFS, good evening. And we have Mick 002003, good evening. Who else is here? Who else is here? I think I say good evening to everybody. 8-bit repair also. Good evening. Yeah, let's start with some BIOS. So this is going to be my BIOS. Without this one, I can't start. So tonight we're going same with an Italian one, but this one is called Menabrea. Birra bionda. Birra biondas mean blonde beer. Okay, cheers guys. Let's start how I usually start. With a glass of beer because it's Friday, and why not? I'm not fan of going pubs, and at home at least I can enjoy a beer on Friday, right? Easy cheap is a glass. No, so let me tell you what we have here. So we have this is processor, then we have BIOS, we have a graphic card, we have maybe easy chip, charge controller, then we have this one heat sinks, again heat sinks there, another heat sink here, another big heat sink over here with another 8 power transistors. It's a chunky thing. What's there? The cable. It's a really chunky thing. Huh? Cheers, guys.
See, I knock. Also, this camera is not in the right place. Heatsink for the GPU and CPU. That is heatsink for a full computer. And it's still running very hot. This one says that it's running around 80 degrees on normal condition. And our issue what we have, so on this board someone else worked on, changed some capacitors there, changed the power transistors, and suddenly is not, you can't control anymore the bias, and it's going straight away on almost 10 amps. 10 amps on quiescent current. Yeah, in the winter with this amplifier, you can play music and heat up the house. Yeah, so I hope the audio going how should. So let me play an intro about this amplifier a bit. So let me just go there. Let me open this one and play this one.
So we have
okay, which one is this? And okay. What? Give me a second, guys, because I think I need to delay this
so we
one
have a
from
monster
here.
that come in for repair. Is the Krell
This one I need to
KSA
delete it and play this one.
So we have a monster that come in
So
for
yeah,
repair.
this is a presentation like how is this amplifier is very huge. I don't have space to put it on the table.
It's a very big beast. It's really a monster, and we shall bring it here because he said that someone work on it in one channel and mess it up, and should work one channel and the other channel should have some problem. So this is a dual mono block, has two separate power supplies for each channel, and definitely there is no space that will gonna fit on my working desk. So I need to take apart, take only the motherboard and PCB for one channel and power it with my bench power supply, and try to figure out what's going on. And here we go, this is how it looks inside. So we have one channel properly here. So this is one channel and this is the second channel. So he said that this channel is working, so I look around and I can see everything is connected. This channel I need to take out, so all this apart, this is the power supply now. So I need to take out only this one outside from this amplifier and put it on my table and work on it, because in this side, see, we have cable disconnected. I can see there disconnected also there. So practically I need to take this one to see how this one come out, maybe from these bolts, and then just pull it out, put it on my desk and try to see what's going on. So we have a monster that come in for repair, is the Krell KSA.
Alright, so that was the story of this one. So we have the one that was worked on, which is this one, and the bias is not anymore stable. And I need to understand why. And the unique way to understand on this one is to transfer components from this to this one, because I already take out all the transistors over here out one by one and test them, and all of them they test okay. But the problem is, because are quite old, under the high voltage, some of them they have some leakage and get shorted, and you cannot control the bias. So the only way to test which one is the problem, I need to transfer and test them one by one. And in order to make my life easier, I need to take the boards from here, do some jumper wires to connect to these ones over here, because you have wire that goes to the power transistors. And I can keep my power transistor out the way there, and the boards over here to change the transistors. Yeah, there is so this is the bias potentiometer over there, and this is the DC offset potentiometer. On the low voltage, if I power the module with 30 volts, it's working okay. But the power supply on his case is dual 60 volts, so a total of 120 volts. And when I go even at dual 40 volts, already something is going crazy on. So as I say, I already desoldered all the transistors once, one by one, put them on the tester, test them on the tester, everything looks fine, there is no any shorted transistor or something like that. Even also the diodes, if you see, it's soldered there, fresh soldered, because I take them out and I test them. Even everything tests okay. If I need also to measure all the resistors, everything tests okay. And if I go to power under 30, dual 30, so it's a total of 60 volts, working good. As soon as I power with more than that, because the transformers there on his case is, as I say, dual 60 volts, so a total of 120 volts, that's it. They have a DC offset of 44 volts, and the bias goes crazy, maybe like 10 amps, and it is not normal. So at least I have this one that is working. So as soon as I transfer one by one components on this one and this one going crazy, I'm gonna know which transistor then is a problem. But I'm gonna start first with the bias. This is in charge of bias with this capacitor. So I have this capacitor, the pot, and two resistors here around that is in charge with the bias. So I'm gonna start with that one. And we start from there. But first I say, let me run some jumper wires to have the heat sinks there and to have only the boards next to me. Yeah, Carter. What I read about this one, it says that in quiescent current should be somewhere 2 amps per board, so in total 4 amps. Give me a second, my little boy. What happened? All right. My little boy was shouting. Okay, guys, so let me start with that job, because otherwise I will not be able to do nothing. We're going to stay here on telling story only. Right. So first of all, I need to undo this. These big bolts over here. Big bolts. Where did you fall down now? Where they lost the bolt. I needed to zoom out all the way my camera, because these ones are huge, man. Very huge. Very, very huge. Okay, where's the fourth bolt? It's in there. All right, so I need to use 2 soldering stations, because One is for desoldering and one is for soldering. Right, let me set up my solderings. So this one we're gonna stay on 280, yeah? And this one for desoldering in 350. Okay. So let's start with this one to take it off from there and run some jumper wires. And I need this one also. Have a look at my very tiny tip. There's my camera there. So I'll not be able to share with you the power supply because this one is powered with 3 wires. So it's a special power supply for that one that is not, I don't have a computer interface to it. Right. So, see, now I can run some jumper wires and I can keep the heat sinks over there away from me. So let me get some wires, enough long. Run some wire from here to there with the chopper. So I need 4 wires. So some length like that. We'll be able to do 4 pieces. 2, 3, 4. Yeah, something like that. Something like that. And 4. Let's get all the same length. So how is going, guys? Everything all right? Weak and nice? They should be enough now. I have there 8 pieces and then this side 8 pieces. Right. And we need to start doing. So let me find also my heat shrink. Because I don't want to get shorted knotting around over here. I have a piece of heat shrink over here. And let's start putting them. So do one by one. A soldering wire. Right, so let's do red with red. Red with red. Let me put a bit more high temperature. 330. So red with red. And I'm gonna go yellow with that orange over there. So there is few reflection because I have only one light. Soon I should receive the second one, and I'm gonna put them a bit away. Like that in the middle will not be reflection. And I'm gonna have plenty lights. I say that I go yellow with orange over there. I'm gonna do green and blue for these browns over here. Like that, these ones, they can stay there and I can work on the boards. And that's the thing, that here, fixing amplifiers like that with the differential power supply, the thermal camera and voltage injector here will not be having any effect. You can't, because only this one powering normally, it must be hot. So if it's not hot, this means it's not working. So you cannot have an idea like something is getting hot or whatever is in short. No. Right, so these three, this is fine. So let me also put some heat shrink on them because I don't want to short them. I don't want to get shorted. So better put some heat shrink on. Better we put some heat shrink on. And if they stay like that, without tightening them, it's good. It's good. Because anyway, I need to take them down then once the board is fixed. Take off the joint and solder back the short wires. So if they stay without to make them tight, that's a bonus for me. So I can take them off then easy. So what will explain a 10 amp draw? So practically the amplifier, when you need to bias it and put it on quiescent current, they need to draw around 2 amps per amplifier without playing any music in. Then when you play music, yeah, they can go also maybe also to 20 amps of power or whatever. But without playing any music, just sitting there continuously, you need to draw 2 amps per channel. But this is the problem. This one, without playing any sound, only nothing, is drawing 10 amps in quiescent current, which is bad. I don't know. I look for prices. The prices goes somewhere on £3,000 over 3,500, 3,000 or something. I don't know. I don't know if there is any more new. This one you can find them because they are not producing anymore. This amp. This one was a British-made amplifier. I don't know, around the 80s, I believe. And it was a really piece of audio gear liked by audiophiles people. So that's why a second-hand one. So first should go in this point. Let's shoulder there. This point. Second wire should go there. That's why new, this one, no, you will not find anymore because this one was produced in around 80s. And I saw some prices around 3,000 something, maybe also £4,500. We were gonna have a look because I need to look also for some data sheet because these four here are also obsolete. They are not producing anymore this kind of FETs over here. Are not MOSFETs, are FETs. So they are not producing anymore these ones. So I might need to look the data sheet to see if any of these one is bad, to see which one is a substitute, because this one, that model, you'll not be able to find in the market anymore, are obsolete. These ones here are four FETs which are doing the mirror current for the first stage, where is the amplifying the voltage, because this one do the voltage amplification, and this one at the back doing the current amplification, the power. And there is two of this one do the input stage, two of them handling the feedback, and these ones, they are mirroring the current on these ones. So that's why this one. And then you have these one are the drivers for the power transistors. And here is the yeah, the sound of this one is, if you go also, you search about the sound of this one in among the audiophiles and those people, there's those people that they are crazy to have the purest sound possible in the world. They also recommend this amp as one of those ones that had no distortions, had no colorating the sound. My neck, oh, I have one that is designed by myself. I designed one by myself. The schematic, everything, I designed it by myself one. It's also, that one sound amazing. Has a pure sound. Same, need very huge heatsink because it's same a class A also, that one. Right, so let's get again. So I go with the yellow for the orange one. Yeah, you're gonna see me more. Let me just finish this one, putting the jumper wires to them, because I was thinking how I can do a better way, and there is no better way to do. Only like that I can do, to have everything soldered in place, easy cables to put the power on and to test. As soon as I change one transistor, swap it from the board to board. And as soon as I saw that the problem that has this board is moving to the other board, I know that that one is the transistors that do that problem. Because I say, take them out without power and test them. You're going to see how they test perfect. No problem. It's like a brand new transistor. But as soon you put power on, the low voltage, they're working fine. As soon you go high voltage, that's it, it's going crazy. And can be also another reason, because I see here who worked before, he changed also some transistors here. And if these one are not original, genuine one, and are fake, maybe it's not the same data sheet, and that's why they don't handle that high voltage. They might have this capsule, but maybe inside is not a medium power transistor, maybe as a just signal transistor like this one inside, if it's not a genuine one. And that's why this one, they don't handle too much current, and they go crazy straight away as soon as you give them more power. So that be also like a cause that can create this one, but until I'm not swapping them, I can't understand. Because in order to understand if it's a genuine or no, this week I was chatting with James about curve tracer. Yeah, curve tracer can show you definitely if you have a genuine transistor or is a fake one, because a curve tracer needs to match exactly the curve that is provided on the datasheet. And if that curve is not matching, when you test the transistor with the curve tracer, that's it. Definitely is a fake transistor and is not an original, genuine one. So this one can be the causes here. Who worked before, if he might swap any transistor there and he put a non-genuine one, maybe that's why he's doing this problem. Because as soon as you feed it more voltage, is going crazy. It's like not handling anymore, and is going like to short himself. And at least it was shorting properly, totally shorted, like that I can find it when I take them out one by one and test them with the tester. But no, the testers say that are okay. Right, it looks good. Where's my heat shrink? Yeah, it's full on the market of fakes transistor or fakes ICs also. What do you think? It's full on the market. That's why you need to make sure that you buy the parts genuine from a trusted seller like Moser, like RS, or it was another one, how is called it, I forget his name, another electronic components seller, how is called it, that one. Yeah, Farnell, yeah, Farnell. On those one, yeah, you can trust. Whatever you buy from those one, you are sure that it is a genuine one. It's not other kind of. Let's see, you want to buy an AMG power transistor, and inside the capsule you find a BCE 109. So, guys, you need to watch me doing twice this job because I need to do both of them. As I say, I need to swap components around. No other. Oh, PCDD repair. How are you tonight? Right, so this one should be the first one. The second one I say is a green one. What has to build the Carter? I was not at the. I don't see the message. What he said that he wants to build. Then should be the red one, and the last one is yellow. Okay, Carter, what you are building? Dave, you make a video or you make a stream, but what is that? It's a calculator kit. Ah, yeah, nice. Nice. It's based on STC? STC microcontroller, or which one has like a controller? Or is an Atmel microcontroller on board? Stay there. Stay there. Right, so one is done. Still a bit aside over there. It's going to be the second one. And we can do the second one. All the wires are ready over here. I wish to have a bigger table one. Maybe one day, yeah. Yeah, this is a laptop PCD repair. So we have here the big processor. It's a quantum processor, that one. And here we have the RAM, memory RAM here. This one has a heatsink. Then we have the SSD over here. There, it's quantum processor. All right, let me do also this side. Because otherwise night is coming and we're gonna not finish doing nothing. Let me get these bits and pieces over here. All right, where is my special bolt opener? We have very big bolts over here. I don't know how to set up that stream elements. Someone needs to teach me. I don't know how to set up that stream elements. Quantum processor. Yeah, it's a quantum one. It's the most fastest AE processor, this one. Artificial intelligence. What do you think? Need a lot of heatsink to cool it down, because it's processing very fast the data. All right. Let's do also this one, and then we can do some fireworks, right? We can do some fireworks. We can take down the power for all the building over here. This one is power hungry. That part come off, no problem, because there is a part underneath. Because actually the trace is underneath, is not there. It was just a part there. And very old PCBs, this one, they don't withstand too much time soldering and desoldering, you know. We're gonna sort it back, that one, no worries. All right, so the board is off. The board is off. We do a second time the same things. Where are the wires? Where do I put the wires? Here. It was really fun to PCDD. What do you mean? What was fun? Huh? What was fun? Okay, let me change the tip on this one. Let me change the tip on this one. The only problem that I need a pliers, because this one is not the C245 is a T12. A T12. And only like that I can do. It's better if it's a bit thicker for the wires. Then I'm gonna put it back when I need to solder the components, the thin one. Better if it's thicker. Yeah. Right, so at the very end I say this yellow. It's really fun to PCDD. What was fun? By the way, guys, tell me if it's dropping any frames or something is going wrong, because I think I'm streaming again to 1440. Okay, so let's start with the yellow. It goes to the orange. And we have the red with the red. That goes to the red. Then is coming the green. Yeah, only this is the unique way that I can figure out what's going on over here. Because I never see such a things. The components measure perfect, everything is measured okay on the board and is not working.
Thanks for the sub.
Oh, thank you so much. Really appreciate that one. Rockabilly, something like that. Yeah, sorry guys, you need to see me doing twice this, but this is what we need to do. There is no other option. No other option than doing this twice the same job. The thanks for the sub is quite loud. I don't know from where to regulate the volume on that one, you know? I was looking around, I don't know from where. Let me have a look if it's for the alerts. Because it's from the alerts, but I don't know which one is the volume for that one on alerts, you know? I'm gonna have a look. I don't know now where how to check that one because it's something from alerts, but I don't know where I need to touch the audio in there. But thank you that you let me know that it's quite loud. So for the next time, I'm gonna make sure it's adjusted. Because now really I don't know where to touch. I think when I set up those things, was James helped me to do all these settings. So I might need to ask him from where I need to set to put the volume a bit lower. Because honestly, I really don't know. Because he helped me to set up all these tanks for the sub and alerts. he connected to my computer from here, from his computer, and he did all these settings to my alerts and notification for this if someone subscribe or something like that. Or if someone give me a tip or something like that. Hey guys, the last 4 wires are also done, and just to solder them to the board, and then we can power them and see what's going on. Which one is the boo-boo? We need to find them. Okay. Heat shrink time. We need 8 pieces, no? 4 in one side and 4 in one side. So 3, 4, 5, 6, 7, this in half. And let's put here. These sheet shrinks, don't short them out when I move the boards around. Go in, huh? This one doesn't want to go in this. Yeah, Carter, blame James. He's taking all the responsibility for this. At least we have someone that is taking the responsibility, which is good. Right. Okay, so one can sit also there at the back. Now, it's a matter of time to solder the wires over here on the PCB, and we're gonna be right. First one is the blue over there. Yeah, much better this one. Second one is a green. Come on. One is a green. And go over here. Third one is the red. The red I need to solder on the other side, because I need them to rebring the pad on the other side. I'm gonna do a trace repair on the other side later when I'm finishing. Know that it's working. There's no point doing now, because first we need to find the boo-boo. Once we find the boo-boo, then we know everything what we have to do. Until we don't find the boo-boo, it's pointless doing things. First we need to find this boo-boo. Right, let's do also here. Starting with the blue. Starting with the blue, which doesn't want to stay there. Ah, I stayed there. Wait. See, doesn't want to listen to me, this cable. So, come with the blue over there. Right. Then we have the green. Okay. Red. Last one is the yellow. Last one is the yellow. Alright guys, let's have some beer first. And there is no activity on chat. Did the chat get blocked? Huh? I'm gonna just miss a second to have a look on my little boy. Alright, I'm back, guys. Test. For sure we're gonna test. Don't worry, now we're gonna power, because I need to show you what it's doing. I need to show you what it's doing. Alright, so for now, I can put away these ones from here. Can clean a bit the table to make sure there is not this kind of thing underneath, because shorting out the PCB. No wires, no solder underneath there. No wires, no solder underneath there. And I need to set up a few things here, because in order to test. So let me just take a bit from the way, these ones, just to don't be here in the middle for now. Let's get them later back. Then take them later back. So I can switch them off for now. Right. Because we need to do a few things here. You cannot just power this one like that. We need to make sure everything is under control. Right, so we know that channel is there. We know the second channel is in here. I don't like these ones. Right. I need to turn that. I need to do a few things, guys. Just a second, because we need to do a few things over here. I need to bring my multimeter first. Let me bring the multimeter on here. All right. Uh, 15. Okay. Okay, so we have the multimeter there. This one will gonna be our for voltage measurements, okay? Because here we need to measure voltage. Then we need this. I need this. They're gonna monitor our currents, these two guys over here. Alright, so they're gonna monitor this one for this channel and this one for this channel. Then we need our speaker. This one it will gonna be our speaker. This is our speaker. The load resistor. We have our speaker over there. Our dummy load is going to be our dummy load. So let's connect first the speaker. So this is my output speaker. We're going to be connected to this channel. Alright. There's my ground wire here. Ground wire for speaker is this one. Alright. That's my speaker. Here also. Where is the yellow? So this one is my output speaker. We're gonna be the second speaker over here. Right. We get also the ground over there. Ground for speaker. Ground for speaker that goes there. Right. Now, as I say, this is one amplifier here. Put this to don't touch it here around. That'll be my shorting. Right. So this we're gonna monitor the current on this. And this one we're gonna monitoring the current on this one. Okay? So let's get, we have ground and amperes. Then we have ground and amperes. Right, when you get the power supply ready, so we have, this is the negative, this is our negative, which here I have an issue. I need to do some different things. Hold on a second, guys. I need to do some things over here, because these ones, they need to stay something like that I can connect these two together. I need to adjust them somehow. I can connect these two together. So what if I were gonna do like that, and this one like that? Okay, I can bring this together over here. Yeah, so we're gonna be like that. There's no other option. Or otherwise, let me try to find another jumper lead. It's better to find another jumper lead to connect those one, because I don't like the wire how they stay. I need to find a jumper lead. Just give me 1 sec, guys. That one can stay back there. That was the best option. Only that I needed to run a jumper lead to these two. To these two. Okay, so let me find jumper leads, guy. Some thick ones, you know. Where do I have them? Where do I have them? Where do I have them? Maybe they can help. Maybe they can help. Maybe they can help if we find here everything what we need. Let's have a look. Let's have a quick look. I think we have only these big ones I have. I don't have smaller ones. Fuck. Alright. We have only this one, we use this one. I have also small ones, but I don't know from where to look now. Maybe they should be here around. If we have only the big ones, we use the big ones there. Alright, so I need this black one, because I said that one is our negative. Let's keep the colors. So I have our negative over here, which goes connected to that guy. Right. I'm gonna go connected to this guy. Or negative, okay? And I need to somehow to connect also that one there, because this one comes from the power supply, which is the negative voltage. Then I need to connect our ground, which is these two together, this with this. Before that, make sure here, this one they don't touch nothing there. Stay there like that, yeah. Let me connect also these two together with another jumper wire. This is gonna be our ground. Our ground. Okay. Let me one thing, because thanks to PCDD Repair, he made me a gift, some tape. So let me put some tape on these ones, so that they will not short here around. Make sure they will not touch things that they don't need to touch, these ones. Good stuff so far, bro. Yeah, that will be bad. Can you bear? Okay. Good stuff so far. Dummy loudspeaker, banana leads are good. Got a full bag of them. Yeah, Carter, it's the most things that you need to have them. If you really do electronics without these jumper leads, you will not call yourself an electronics. You must to have them. Right, so those one are isolated, I believe. You will not touch nothing there around. There is the ground, so I might do also to the ground, because I don't want the ground to touch the power transistors and make some fireworks around here. As long as we isolate also these ones, make sure that no fireworks is happening around here. All right. Then they can go whatever they want. This is I have a small bench where I'm working. If my dream come true to move to maybe a house with the shed, and I can move my things in a shed, will be Great. Right, so we are isolated there, so I don't care now if they go to touch something, so I don't need to care about them. So these one are okay, these one are okay. So now let's set up the current monitoring. So I say this one will monitor our current for this channel. This means this needs to go connecting to positive over there. Okay. Connect to positive there. This one, measure the current to this guy. So this black wire should go to positive over there. And let's turn them on. And let's put to the current. It's already automatically. This one, you know what's nice on this one? Look, if I want to measure, is what I want to measure is going, I believe, by itself. Or this one, I don't know. One of these multimeter is going by itself. Depend what I want to measure. See? Oh, actually, it doesn't let me to move. See? I want to move from here, from this function. Doesn't let me to move. But if I remove the lid, see, I can move through the functions. But if I put this one here, it's jumping straight away. He knows that only amps can measure over there. Have you seen this multimeter? See, I'm taking out. Next, I want to measure resistance, right? Look, I'm gonna put for resistance. See? Oh, that is beeping mode. Resistance, okay? And look, I want to measure current. I only plug this one, and it's going alone to current. Okay, so that one, it's gonna be our current for this guy. And this one will gonna be the current for this guy. So where are you amps? Here on this side. Right, so this is our ground, so let me connect our ground. So it's gonna be here connected our ground. And this is our positive that goes to be connected to our multimeters. So there and there. Right. I hope that you can see the multimeters, because only like that I can show you what I'm doing over here. So I say this measure the current on this board. This measure the current on this board. Okay, I'm gonna turn on my dual rail power supply. And I'm gonna set to, why you are beeping? You're beeping because the battery, I need to charge you. I think this one needs to be charged. All right, so let me set up the voltage. As I say, for beginning, I'm gonna start with 30 volts to show you on 30 volts that everything is correct. Both of them, they are working the same. And as soon as I put then more higher voltage, this one is going crazy. I'm gonna turn on now the power supply. So you can see almost the same current is drawing both of them, both channels. Oh, sorry, I'm in the current limit on my power supply. So let me just adjust the current limit to take out the current limit. Let me take out the current limit. So current. Let's give him. Let's give him somewhere there. Current. Right there. And let me get my, this one needs to be charged. I forget to charge them. Let me get my need some tools. Small screwdriver to adjust the bias and everything there. Here. Now this one. Yes, I know. Forget to charge you. Let me put charge on you. You are gonna work. My head it will gonna go in the middle. Sorry guys. Sorry guys, because I need to find the cable for this guy. Which one is the cable of this guy? Which one is the cable of this guy? Because right now he decided to don't have power. Right now, until now was okay. Okay. Sorry guys. Let me see if I can put on charge while I'm measuring with him. Because he's crying. He's crying for power. Alright. Let me connect to USB. Wow, really? So I can't measure while it's charging. Okay, I have lots of other multimeters. Let me find another multimeter. Just a second, guys. Right, where are you? Other multimeter. Where are you? Other multimeter. So it should be over here. Should be this one, huh? Maybe it's fine. Anyway, I get the new one in case that doesn't work. Let me unplug it and try now. Right. All right over here, still beeping. Let me turn on the power supply. So you can see, while is just powered to 30 volts, so let me measure the voltage like that. You can see that it's 30 volts. So we have ground over here. This is our ground over here, where is the green one. Right? This is negative. So you can see 28 minus 28. And this is our positive in here, this red one here. And you can see positive 29. So we are there about 30. And on the speaker output, we should have 0. Let's measure the speaker outputs. So 20 millivolts is fine. The other channel, 20 millivolts is okay. I can also lower to 0, but just to show you. So I can see on 30 volts, both of the boards working fine. So this is drawing 2.8, so I can lower. So where is that port? So let me just lower the bias. Maybe my head is coming in the head, sorry guys. I need to find the guy over there. So that is increasing. And the other side, I should decrease. I can bring it down to 2 amp exactly. Because that's what says the normal operation. Quiescent current should be 2 amps. The butt screwdriver. So 1.9 is fine. So that is down. Let me also regulate also this one. So that is, see, already here I cannot get lower than 2.4 because that's the minimum one. I can increase it, but I can't go lower. They were gonna increase, see, going up, but the minimum port, just the end of the port, here is the end of the port because it's clicking, is already high, see? Sound, if I put normal speaker now and I put a signal on the inputs, these are the inputs, I have nice sound really nice, no crackling, no hum, no hiss, nothing. And yeah, that one is the problem. If you can see, living like that, it's trying to settle by itself down. See, it's keep going slowly down. I can see there. So something can be bad. I say everything what is involved on bias is this one here with that capacitor, with the port, and another 2 resistors here in the board. So those are the bias circuit. So I might start with that one. I'm going to take the transistor from here, move it in this board and put this one here and see then if this problem shift on this side, we identify the problem straight away. Because I say, if I desolder that transistor and I'm going to put it on the tester, I'm going to show you, measuring perfect. There is no problem with the transistor. So that's why I desolder it, I measure it, and I solder it back because the tester was showing me that the transistor is fine. Is that what I need to do? I need to start with that one because this is the bias. 2 resistors. The resistor already I measured it before are correctly. Whatever measuring here, measuring also there. The only thing that can be maybe the capacitor under voltage getting leakage and try to short him because the capacitor on the schematic, I'm gonna show you, is connected properly from the collector and emitter of the transistor, which regulate the current to flow from the PNP transistors to the NPN transistors. So this one, that's why it's keeping the transistor too much open and doesn't like. No, the pot is okay. It's working perfectly. I tried it. Actually, are new because see, I have blue here and these one are green. So these one are the original old ones. These one are properly fresh ones. So are okay, the pots. Because look, let me increase. See, it's working okay. The pot, look. See how it's going up the current. But the problem is at the end of the pot, if I bring also this one till the end, I should have like maybe 800. Sorry for my head in the middle, guys, but I need to find the place for my screwdriver. And that's increasing. This way decreasing. So look, I'm gonna tell you when this one is at the end of the course. Still I can lower, I think maybe at 800 milliamps. There's something wrong. So yeah, let's start with that one, guys. I'm gonna desolder this one, and I'm gonna put it here. Take this one from here, put it here, and we start from there. Because only like that I can identify it. Right, so switching off here the power supply. Taking some leads off from here. So let's everything leave it like that connected. We're gonna only do, and in the meantime let's put this one to charge like that. We're gonna not beep here all the time. Let me put back on charge this one. Charge there. And let's do what I said. So I'm gonna disconnect these wires a bit, only the powers. Make sure I'm not in the middle over here. And let's start with that one. So I'm gonna show you some method which I use to desolder easy. But first, I need a screwdriver to undo the screw because are tight on the heat sinks. So let me get the right bit over here. This one. Yeah. Still the right bit. And we're gonna start from there, guys. There's no other option. Get this one. Okay, there is lots of fireworks going on outside. And my little boy is scared with the fireworks. Maybe he was gonna start crying. Why? Why they are doing this firework? What's going on? Is it Chinese New Year? Is it? Oh my God! I don't know if you can hear them. Let's start with the bias. Oh my God. My little boy, we're gonna wake up now, we're gonna start crying because he's very scared with these fireworks. Right. No way, man. Alright, so Emma. You can stay there because you have longer cable and I can use it from there. Right. Let me turn it on. And for desoldering, I'm using a very big head. A very big one. I think it's 5-6 mils, that one. Very big one. 350 degrees, and use solder to desolder. Did you know this technique? To use solder to desolder. And that one is dropped by itself. And here should happen the same. Use solder to desolder. And that one dropped as well. Right, so we have one transistor, which is from this side, so let me keep them together here to know which one is which, because I'm gonna also measure them to show you that they're measuring okay. But maybe under the voltage, they don't measure anymore okay. Okay, that's the method, use solder to desolder. Have you ever heard about this method? Have you heard about this method? Use solder to desolder. Okay, so I have a small transistor tester around here. Let me reach to it. Again, my hand is going to be on the way. I need to use that one as well. Did I put it back there? No. Okay. I know where it is. Give me a second, guys, because the transistor tester, it's in here. All right. So that is using to charge there. Can I have a normal micro USB around here? I should have a micro USB around here. Where is the micro USB cable? When you need cables in that moment, you don't find them nearby. Where are you? I have it before. See, I found it. Because everything on my working bench is low bat. Even this one is low bat. Everything is low bat over here. Right, so this one is from the channel that we know is working okay. So if we stick this one here and press the button, you can see measure okay, and it says that is HVE 79, VBE is 567 millivolts, and that. And now measuring the one that the board is not acting how should. Press there. This one is telling me HVE 87, 571 millivolts, VBE. So see, it says that it's okay, the transistor, so it's not a burn one. Okay, so now this one we're gonna solder there, and this one solder there, and we power again. Because only like that I can get to the end. Right, first it's a solder. I need to wick there. I need to wick there to make the holes. So I try to use this guy. Let's try to use this guy. 300. Let's try to see if I can do this one. If no, I need to use the, how is called that one, the wick or braid. How you call it, guys? That one is gone. Second is done. Come on. Let's do the third hole over there. Third hole is good. Let's do also on this side. Well, I have that, I have also that desoldering station with the pump straight away. But until I get also the tubing from that one in the middle over here, I'm gonna get so too much it's Halloween, that's why there's all these fires. I should have a costume like that. I can do an electronic video in costume. Sorry guys, I was not prepared for that. I definitely was not prepared for that. Why you don't come out from the... Okay, use solder to desolder. Again, where is my solder? Use solder to desolder. Yeah, go there. I think my pump is getting stuck. It's not sucking. Yeah, now it's sucking. Yes, that's the second one. Let's do the third one over there. It's getting full of solder over there. Look how much solder has there. To put solder to the solder. Something is wrong there. I think it's full of solder underneath. Yeah, too much solder underneath there. Give me a hard time this last hole, man. That's it, it's done. So much solder, man. Right. Let's put them back. Okay, so this one comes from the good one. I'm gonna go in here. One thing I want to know here. Is this the trace? Maybe that one is all the problem, because I think that trace is broken. No, it's okay. It's a good trace over there. Okay. Let's give a quick clean over here. Maybe with this one. Okay. Yeah, I should wear a costume for Halloween, man. What? It's not clean, that hole. The middle one. It's not properly clean, the middle one. Still need to clean the middle one. Think this one I'm gonna do with the pump, but the next one I'm gonna use the braid. Make me crazy, this pump. And the middle is not yet cleaned. Huh. To clean, needs to use more solder. And then it's not coming. And tell me how many degrees I have here. No, I don't like. Let's use braid, man. I don't like. Let's use braid better. Let's use braid. Let's use braid better. When the braid doesn't help there with the middle hole, man. I have another technique. Toothpick. Toothpick will gonna help. We go from the other side. Toothpick definitely gonna help. Right, now we are fine. Let's get this one back. Yeah. Solder ball over there. I don't want solder balls there. Now a side hole is not made, but looks like it's made. So what's going on with this board? Right. Need to use this method. Right, that's there. Where's the mica washer insulator? I lost it now. We need to have insulators, otherwise they're gonna short them by themselves. Okay. And that one. Stick this one underneath. Tie them. All right. Let's mount the other one over here. Then we're gonna solder them. Right. Already I saw a difference between this and this one. The legs on this one are thicker. Definitely thicker. Why might be this one not an original one? Who knows? We're gonna figure out now. We're gonna figure out now. Once we're gonna do all this transfer. Die, Mika. Right. It's full battery. Okay. Okay. See, that's why I don't like to pump. Get a lots of solder everywhere. So yeah, I'm gonna use the braid and toothpick. And with the sucker, you make solder everywhere. Look what a mess. Look what a mess. Oh, you are beeping. You already feel fully charged, and now you are something wrong with that one. Something wrong with that multimeter. It's telling me that it's fully charged. Right, let's solder quick. Let's solder quick. Okay, that's solder. Solder also here. Because these boards are those old style boards, and you need to solder both sides, because I don't know if in that time they already know how to make vias. Right, so these one are all fine. Let me put a bit on beeping mode to make sure that there is no any shorting around there. Let's measuring the beeping mode. Make sure that we don't have any short around those. So it should be base, collector, emitter. It should be base, collector, emitter, collector and emitter. Good. Should have base, collector, emitter, collector and emitter. Good. Opposite should not measure nothing. So collector, emitter, base emitter, base collector, okay, okay, and okay. So there is no any short. Make sure that there is no short between this and heatsink. And yeah, BP. All right, so let's get a test again. Let's get the test again. Let's get the test again to see if now the drawing current moving this side, and if move, we know what is the boo-boo. That one. Let's have a look. So here we have everything all right. We need to get the power supply, so I have negative, which is going to negative over here. We have our ground, which is going to be here, the ground. Then we have our positive, which is going to connect with the multimeters. This one, turn on this one as well. Let me make sure that there is no solder underneath. Okay, let's power. So yeah, still here is the problem. Still here is the problem. So next one, I'm going to swap the capacitor, because capacitor also has to do with this. So we swap that one, still the problem is inside. I need to swap that capacitor now. Right, guys? Those onboards look like headache. You will most likely need to trace and make a schematic, as feeding this amp is impossible. Ah, we have the schematic. I know already schematic, everything in my head. I know already the schematic. I have also the schematic, but already I memorized the schematic, is in my head. Definitely we have something that under voltage measure bad. So next time is the capacitors. Capacitor can do the same, like when they go voltage, they can short themselves when it's under voltage. So let's go that capacitor next. Because the problem is still there. So if the problem is still there, next one we go with the capacitor. So the capacitor are these two pins over there. Alright, so let's get the capacitor down. Power is off. I have here and here. Just a second, because these boards are so shiny that I can't see the trace on this one. It's just a pod. The trace is on the other side. Yeah, traces are on the other side. Right, let's get this capacitor out from here, because this is the next one involved on the bias. Right, and the capacitor, we can test it also, this one. We can test the capacitor. Let's see what the capacitor say. Test from there to there. capacitor, measure quite good. 100 nanofarads, 0.39 ohm ESR. See, it's measuring okay. I do have some brand new ones. This one, 100 nanofarads. I try to change. With these ones. They are brand new. I might try to see with these ones. Rather than swap, so I try to put this one rather than swapping. Right, where is my braid? Let's use braid to get out there because I don't like the pump. Let's use 400 degree. Yeah, braid is better. Look how nice the hole comes. Some leaded solder. Toothpick. So that I don't make too much mess here with soldering on my table. Right, let's try to put this one. This 100 nanofarads. Try to put that one, a brand new one. See if anything changes. What I used before my chopper. Let's use a brand new 100 nanofarad just in case. Let's see how he's doing. Right. So here everything is okay. There's no issues around here. No issues around here. Put cables are correct. Let's power on. Still the same. Still the same. Still the same. 2.7. Let's hope something changed. Look, Carter, nothing changed, man. Nothing changed. Brand new capacitor. And still the same. Still the same. Still in high. Let me just have a look in this diode zener which voltage I have, because also that diode zener, if are not okay the voltage, they can impact to the bias. We have the ground over here. Wait, to change to voltage, sorry. Change to voltage, DC voltage. Yeah, I know you want to sleep. Which voltage we have in here? Here. So we have minus 24, and here plus 24. So also the zeners, they are working perfectly. The zen is working also perfectly, because if I go here, I have exactly the same voltage. Minus 25, yeah, 1 volt is not any problem. Plus 25. So the zeners are okay. But still we have an issue there. Still we have an issue over there. Remember that was putting positive voltage on the output with the high voltage. So this means this is the positive in this side. So I'm gonna start swapping these guys. This and this, because the bias, it's opening these two transistors with these two. So if these one are my going bad and shorting, all the positive voltage goes, because in the middle it will gonna be our output, the speaker. We're gonna put more positive on the output. So we're gonna try swapping those. Yeah. These ones. Okay, let's go with the next this ones here. Because I need to find which one is that one. As I say, I measure them, they measure okay. Only swapping around I can figure out which one is the problem. I'm gonna might take all night to be here. So my wife, she need to come home. Oh my god, it's 10:27 already. Maybe I'm gonna go tomorrow also on live stream. Okay, I'm gonna continue with that one because mostly the positive side was giving me problem. So where is my screwdriver? Here. So let's start with this one. Right there we take all the way around. Because there's no other option. To figure out which one is the problem one. Only like that we can understand which one is the guy that has a boo-boo. Because you're gonna see, take these two outside, they measure correctly. Look, all of them, and still they're gonna measure correctly. Right. Using the same method. Lots of solder. The transistor will gonna just fall down by itself. Same also here. Lots of solder. The transistor will gonna fall by itself. Right, this is off. Give it clean like that. I can wick from the other side much nicer. Let's do the same also here. Clean that part on this side. And wick it from this side. Where's my wick? Right here. Yeah, switch off also you. Nice. Let's do the same also there. Why this board is taking more heat? I don't understand. Right. Okay. Let's measure, test also these two. So see that they measure perfectly. But this one is for the bad board. This one is for the good board. Right. Where is the tester? So the good board. Looks the transistor is okay. I'm gonna go to this board. On the bad board, gonna go to the other side. So let's measure also this one. Transistor okay. Okay, Carter, have a good night. If you're going, I'm off bed now, guys. See you all. Ah, the Mick is going to bed. Okay, have a good night, Mick. Yeah, because it's an ammo, that one continuously beeping, not because of the battery. But I think I need to go to option. I think I can take off that one some way. At a long time I don't use it, so I don't know how to, what I need to touch also in that one. This one I always need to use them when I do amplifiers, because you need lots of multimeters when you do amplifier. You cannot do everything with one multimeter. Right. Let me swap this one. Let's Swap that one. Let's also put this one and then solder in once both boards. Yeah, I got like 300-400 multimeters and then some benchmarks. Yeah, man, you need them. You definitely need them. You do a laptop or you do a console, yeah, one multimeter is enough for everything. And when you do amplifier or do this one, no. Because you need in the same times measuring maybe the output voltage to make sure it's zero. In the same times monitoring the bias current. In the same times measure also how many voltage you are putting in. So yeah, only one, it will never be enough. If you are going to fix also amplifiers and stuff like that. As amplifier, you will not be able to fix it like how you fix the laptop. You inject voltage and that's shorted. No way. An amplifier, you'll never see to do that. You inject voltage and you say, oh, that one is shorted, that's it. No, no. You don't see amplifier, how coming? I have positive, I have ground, I have negative voltage. So it's coming 3 wires to power the amplifier. My head is in the middle, sorry guys, I need to have a look here because I'm using a thicker bit and to don't make a short between pins. Okay, let's give a touch also on this side a bit to these pins. Because the old style board, and sometimes I remember the old style boards, they don't have the vias through the hole. They have just pad in the side and pad in the side, and you need to solder both sides. That's why I'm soldering in both sides, because these old type of boards, they don't used to have vias between them. So actually via is doing the component lead itself. So you need to make sure you solder both sides, because otherwise you end up that maybe in one side you have continuity in the trace, and in the other side you don't have any more continuity in the trace. Right. Okay. Again, same things. So if you might think that this is a power transistor problem, no, I already tried this board with this power transistor working perfectly, and this board with the other transistor doing the same. So the power transistor, I'm sure, are fine. So the problem is not from there. To say that maybe one of the power transistor is shorted and that one make the current to be so high. No, I already tried this board with this power transistor and swapped in between them, and nothing solved. Then I take one by one, test the transistors one by one, testing okay, and solder them back. Still the same, drawing current. Then I say this is the last option, to swap from here to there. And if when I saw that the problem moving this side, and the component that I move in that way, the last one is swapping the problem, I know that that is the component. Otherwise, there is no chance. Right, so let's turn on this. Let's turn on this. But before of that one, let me put in continuity mode the one on my working bench. Continuity. to make sure there is no any shortage on this transistor. So we have base, emitter, the junction is okay. No, that one base collector, this is base emitter, the junction is okay. Collector emitter, that might be a 100 ohm resistor on the schematic between them. Yeah, that is maybe 100 ohm resistor which is there. Then I have from here to this one is isolated, and base collector, base emitter in opposite side doesn't do any continuity. Actually better if I measure in diode mode. Yeah, diode mode, because I'm measuring a junction. Okay, so we have, this is the junction F500, 500 millivolts. This one will gonna give me a beeping because it's a 100 ohm resistor down there, and the threshold of beeping is, I think, is 500, something like that. See? Then we have this one, diode mode. So base collector, the junction is okay. Base emitter, junction is okay. Collector emitter is the same. Is the same. And the junction in the invert polarity doesn't do nothing. And make sure there is no short between this and this. Okay. So they should be alright. So now we should power to see where is the problem. Okay, ready, go. So still in there the problem. Whoa. We need to go with the next one. Still in there. Still in there. So we're gonna swap the next one, and so on. And so on. Until I'm gonna get the right one. Oof. So this one now. Let's go with that one. And but first, let me undo the screw like that it can drop off by itself. Now we're gonna drop off by itself. As I say, I already measured all the resistors, matching perfectly the other boards. So all the resistors matching perfectly the other boards. These ones are part for the how to call that one, the circuit, the one that amplification. You know, when you have the feedback resistor, and then you have capacitor and resistor to ground, is the one that allows more bass frequency to go on the output in that one. So yeah, this one doesn't have nothing to do with the bias. So this one is in the feedback. So that's why he changed these capacitors, but doesn't have nothing to do with the bias. You can see this is our original capacitor. It looks like that. This one I changed it. It's the same value, 1000 microfarad, and put it on the right place with negative inside, the negative is inside, so it's not inverting polarity. I say this capacitor, they are from the feedback resistor, then you have capacitor, and then resistor to ground. So it's that circuit here. So and then from there you go on the base on one of these transistors, the one that facing the feedback. So they didn't put like 1K port. No, it's a 5K ports. And I tried to do also that one. I increased it to 10K, still the same. Still doesn't change nothing. Let me show you a bit the schematic because I prepared it here. So let me just open a bit the schematic to have an idea like how this amplifier is. So let me open this one. And let me see where I can display here. Maybe I change to this one. Where you got this? And window capture. I think it's this one. All right. So let me just play a bit here around to make it bigger, like that you can see it. So with ALT, I need to work out like that. It's not that much good resolution if I make it bigger, but anyway, tell me when you can quite reading the schematic. Okay, so I'm gonna try to make it bigger now. Still can be read it. Give me an input over there if you can still read it. So see those capacitor, the 1000 ISA, see this is the feedback resistor over here, and you have this capacitor and resistor to ground for the feedback. Whatever we swap it first, we swap it this capacitor over here, these transistors, and this one, and now we go to swap this one, because I say when it's going crazy, I'm getting on the output, this one is the auto speaker, I'm getting positive voltage over here. So if it was to come with the negative, it was a problem from the bottom side, but in this case, the short come from the top because it allows the voltage to flow on the output from the positive side, not from the negative. So I'm going to try to play with this on the positive side to swap them. So I'm going to swap these two, and these two on the other board. And if nothing changing, I'm going to go with the negative side. So I'm going to change everything what is in the positive side on the other board. Because it's there everything. So this A, see here there is A. It's going to be connected here. This is the circuit that regulate the DC offset on the output here to adjust it to 0. So that's why this A, point A, go connected to point A over here. And then you have negative supply over here. And you have the positive supply over there on the top. And these diodes go to ground. So yeah. And I don't think so. Changing this capacitor can affect the bias. No. Definitely. I'm pretty sure. Good morning. Good evening. No, Carter. It's like that, right? Can't see the cursor through. But yeah, I see what you mean. No, the cursor of the 5K port, this one, is tighted here. So it's tighted here. Here. Now yeah. So the extremes, so it's like made it not like a potentiometer to carry to the both ends. So it's just increasing and decreasing the resistance because the one end and the middle point is tighted together. So that's why it's acting only as a variable resistor, not as a potentiometer to go to the extreme and with the middle to to read all the resistance. No, it's like end and middle is connected together like that. The other end, when it's going the cursor to this end, the resistor getting smaller. No, like this is the cursor. No, let's see, this is the resistance. So if the cursor go next to this point, it's gonna be like 0 ohm, and when you go in this side, you're gonna make a full 5K. That's how he's working there. And I say I already measured one by one all the resistance, and it's everything okay. I also measure from where to where coming, and that's the schematic that shows. Ah, you cannot see the computer's cursor. Oh, sure. Yeah, because I was, maybe now you see it. If I'm on the picture, you can see it. Yeah, now you can see it, right? But now I cannot see the chat. That's problem. Okay, just let me know. You can see the mouse when I move on the picture, but because if I put the picture, I can't see the. Maybe I can see now also the chat. Yeah, so here, see, this is the transistor that we changed already, the first one, and the capacitor that I swapped it. This is the one. This trim pot is connected here like that. So it's like a line over here, tied to 1.5K. And like that, you know, when you go next to this point with the cursor, you go 0 ohm, and as long you go in this side, you make a full 5K full 5K resistance. So we changed already this transistor as well, this one from the positive side. Now we are going to change this one, because I say when it's going crazy, I'm finding the DC positive voltage on the output, not the negative. It was negative, and it was a problem on the negative side. So I'm going to change this one, and then these two FETs over here, and these two transistors. Because I say this capacitors here is the one that I show you that goes to the feedback. Let's go to the feedback over here. So where is the capacitor? This one, the 1000 microfarads, with he changed the guy that he poked around before. See, this one is the feedback resistor that comes from the output. This is our output, comes here. Feedback resistor, capacitor, and resistor to ground, which when you increase the capacitance here, it allows more bass to come on the output, so it's going to be a heavy based amplifier. If you reduce the capacitance, it will not go too much low in frequency, the output. So that one doesn't have nothing to do with the bias. So only here I have a boo-boo that when it's getting power is going crazy. So yeah, needs to do like that. That's the unique option that I have to find out which one is the boo-boo. Because if I move all the active components from this board to the other board, and the problem is still on this board, this means I need to look for the traces somewhere. A trace is like interrupted, because that's the unique things that I can do. No, that's the only things that I can do. In case if I move all the transistors from this bad board to the good board, and still the problem is on this board, this means there is a trace, cutted trace somewhere, and I need to look for that trace, definitely. There's no other option, right? Yeah, because it's 11 o'clock. I need to switch off the because my wife, she's coming home, so I'm gonna carry on like that, and I'm gonna do an update. I'm gonna do also another video, let you know what happened, like a short. If the problem switching the other side and I find the boo-boo, I'm gonna update you guys with the short, because it's late now. Also, my wife needs to come home. I can leave all my bench like that. Tomorrow is Saturday. I can carry on tomorrow on swapping the components, because only like that I can find the boo-boo. How my little boy say boo-boo. We can be in chat. How many of you still here watching, please? Because this chat doesn't show me how many. Only in the mobile, but my mobile is in charging somewhere. Yeah, I say in Amplifier, I'm honestly, to be honest with you, I was 13 years old when I built my own amplifier. Like, I designed my own PCB. I corrode the PCB at home with that solution, like a liquid that etching the copper on the PCB. So first I needed to draw with some kind of ink to cover where I don't want to etch. So I designed all that by hand. Then with a very tiny drill, I think it was 0.8 mil, I was drilling all the holes where the components come. Then I paint all the traces, and then I put in this ferric, chlorhydric, something like that, a liquid that you put the board in, and then you shake until see that all the copper get etched out from the board. And after that, I go to, because it was that time in my place, it was hard to find a shop with the electronic components, and we don't have internet in that time. The only things that I was getting informed and stuff like that was some magazines and some books that my father had. So I find one schematic in one magazine. So I say, let me try this schematic amplifier. I really like it. So I did already that board. And my father used to have like some TVs, you know, the old ones, very old, the black and white tubes with the CRT tubes. So he used to have some of those ones. Some of them, they was from some his friends that he needed to fix them, because also my father, he was in electronics. So he had these old TVs there, and I went there and I was looking for components, desoldered them from the TVs and stuff like that, just to figure out, to find out all the components I needed to build that amplifier. I went there to find smoothing capacitors, those one. Oh my God! If I remember also now how was my journey in that time. Oh, it was really really something amazing. No, it's all gonna be fixed. Don't worry. I keep carry on like that. I know what I need to do, but I don't have time to stream it. I'm not trying. I'm gonna fix it. Don't worry, because that's the unique part to do. Because I say, once I measure all the active components and are okay, the unique things, one is fake and under high voltage going crazy. So only like that I can find it. I can't find it like how you do in a laptop with the thermal camera to find it. No, you swap one by one, and when the problem from this one swapping to the other side, you know that that component moved all the problem from there to there. So you need to change that component. And if I say you end up moving all the active components from this to this, and still the problem is on the PCB, you need to look for a broken trace. Definitely somewhere there is a broken trace, and you find also the broken trace and you fix it. It's gonna be fixed. I say from the beginning that we're gonna be a little hard work, because I confirmed that one when I find that all the transistor was okay. So I say it's impossible something to don't work when all the components are in perfect condition. It's impossible. So it will gonna be a bit hard until you find the boo-boo. Once you find the boo-boo, you eliminate it and then working. Don't worry. Did ever from my home go back to your home an amplifier that was not working better than the factory? Yeah, and I have a lot of story because, first when I started with electronics was when I was 11 years old, actually. And the first time, and also why my YouTube channel is called Symbol Tech. So in that time, I remember that was a new TV channel that was launched around my area there, and you needed a special antenna to catch that TV channel. So I was myself first one to build that antenna and to have it, one antenna for to cast that channel, and that TV channel was calling Symbol. And from there, all my mates and all the people out there on the town was start calling me Symbol. And all of them, they was keep asking me, can you build also for me antenna? I want also me to catch this new channel, this new TV channel. And then they become that my nickname, it was Symbol. And that's why I make also my YouTube channel from my nickname, Symbol Tech. Yeah, it makes sense, the boo-boo, because only like that you find it. You can't other way to find it. Yeah, my journey with electronics started actually when I was like 9 years old. Because I was always seeing my father next to him. He was soldering, desoldering, making, building things. And my journey in electronics started when I was 9 years old, actually. And when it was 11 years old, I built that antenna because it was a new TV channel launched in the area. And my father, he had a subscription on kind of magazine of electronics. Like every month he was receiving a magazine at home, and it was inside schematics and things like that. And then when I was that year, he received that new magazine, and I go through it, and I find that schematic of that amplifier, which I already tell you that I built it. So it was a good one, though. It was like a bit of classic, like GLH amplifier, but it was a bit modified. It was a bit modified that you could get maximum 100 watts from it. And a classic GLH is going maximum to 15 watts power. But this one is like similar to GLH, only modified at a bit that was going to 100 watts per channel. Yeah, nice, Carter. No, nice. No, don't worry. This one will not leave from my home in perfect working condition. Because whatever is made by mankind, mankind can fix that one, no? That's what I think. Okay, guys, it's 11 o'clock. My wife should come soon at home, so I need to close my... And we're gonna do, maybe, if I got a chance, maybe also gonna carry on with another stream tomorrow evening. Because during the day tomorrow, I'm gonna need to do some grocery shoppings, and then in the afternoon, I'm gonna finish to swap all these things. And maybe tomorrow, if I get a chance and good mood, go again in live stream. Maybe we're gonna listen some music to this one. Before ordering the original nice parts that the owner, maybe he like to refurbish it, bring it on the brand new components, like, you know, the capacitors, they get old, especially the electrolytic, they get dry and they don't working as a new one. But first we need to find the boo-boo. Once we eliminate the boo-boo, then we can upgrade to better components. For now, the mission is to find the boo-boo. Yeah, it's gonna be part 2 soon. Don't worry. It's just taking time. That's the problem, because let's say you need to take off the transistor, swap them, solder them back, power on, see if the issue disappear or it's still there. Again, switch off, desolder, solder back. It's a process that you need to repeat it with each one until you see if it's changing something. If it's not changing something, I say next step, you need to investigate good all the PCBs, and definitely you're gonna have a cut trace somewhere, because otherwise there is no option. Because once all the active components, the passive are not that much problem, but the active components, once you swap them, and if the problem is still in this board, I say can be a broken trace, because resistors, I can't blame them. I measure them already. All of them measure correctly. There is no one of them to measure in a high tolerance between the other, because the good quality resistors are from Dell, and Dell are doing really good quality resistors. So resistance are precise, matching the board. I say once I'm gonna swap the active components, and if the boo-boo is still on this board, I need to inspect a broken trace. I need to find it somewhere, because only that one can lead me to the problem. Yeah, process of elimination, Carter, like that. It's a long, but you need to do it. Otherwise, you say, okay, I will not fix it, and can go like that. No, but this one will not leave my house without being a great glory how we used to be this amplifier. Well, guys, I appreciate a lot that you was here watching me doing these things, and maybe you learn something how to diagnose an amplifier, because it's not like going like in a laptop, injecting voltage and find easy whatever is shorted. And I hope you understand that you need more than one multimeter when you do amplifiers. And for those that they know it, that a power supply is just positive and negative. Look, here we have positive, negative, and ground. So we have 3 wires that we need to care about them. Because if I eliminate one of them, doesn't work nothing anymore. Okay, I wish you a good night to everyone, and see you maybe tomorrow evening. I not promise nothing. I'm gonna see how I'm gonna be in the mood, or if my wife have any other plans, and if no, maybe I'm gonna be here. Okay, have a good night, and see you next time. Bye bye.